We've seen how pipe and tubing systems are fitted and lined up to form connections between components. Tubing is generally more flexible than pipe, but it is still rigid. Tubes must be properly bent to turn corners or curve into small areas, and of course, pipe must be equipped with elbows and other fittings to turn it all. Well, there's one type of connector that is very flexible: hose. Although not as common around most plants as pipes and tubing, flexible hoses are used to carry liquids and gases from one point to another in the same manner. The materials used to make hoses, as well as pipes and tubing, are chosen with particular conditions in mind, such as temperature, pressure, and type fluid to be carried. The difference is that materials used for hosing are always flexible. Now, the flexible hose has several advantages over rigid pipe and tubing. One of the most important advantages is that it allows for movement, large amounts of movement. Imagine firemen trying to fight a fire with a line of pipe or tubing instead of a hose. It would be difficult, even impossible, in most instances. Hoses also are used effectively in hydraulic systems, which by their nature create movement or shock along the lines of their connectors. Hoses can absorb this shock and move freely, while rigid pipe or tubing can only transmit them, which eventually weakens the material strength of the pipe or tube. In addition to their flexibility, hoses are vibration dampeners. Many components vibrate when they're in operation, and the vibrations are carried along the connecting lines. When rigid pipe or tubing are continuously flexed by vibrations, they'll eventually break. A hose will give with the vibrations, which dampens the impact. Finally, flexible hoses tend to deteriorate gradually, while pipe or tubing often will burst suddenly. Signs of deterioration in flexible hosing are cracks or splits or bulges. These signs usually can be detected before a break occurs through careful, routine inspection. Now let's take a look at how hoses are measured and sized. We know that pipe is listed by a nominal size that is always smaller than the actual size of the pipe, and that tubing is listed by the size that is of its outside diameter. Well, flexible hose is listed differently than either pipe or tubing. It is sized by the measurement of the inside diameter. A method called the dash system is used to identify hose sizes. This system works by converting the inside diameter to 1/16 of an inch. So, a 1/4 inch inside diameter would convert to 4/16. The numerator, or the top number of the fraction, is the dash size. This means that a hose with a 1/4 inside diameter has a dash size of 4. It is written with the dash and then the 4. By using the dash system, you can match and connect a hose with a pipe or tube and be assured that the inside diameter of each will be the same, thus ensuring an even flow through the two lines when they're fitted together. Flexible hosing comes in a variety of sizes up to about 24 inches. Now, once the hose is built, pressure and vacuum ratings are determined. Vacuum ratings determine the amount of suction or vacuum the hose can withstand before it will collapse. Pressure ratings are made on the basis of two considerations. The first is burst pressure, or the amount of pressure a hose can withstand before it'll burst. The second is working pressure, or the normal system operating pressure. For most hoses, the normal system pressure may be decreased during operation, but it cannot be increased. Normal operating pressure is usually rated at 1/4 of the estimated pressure that would be required to burst the hose. Thus, the safety factor for hoses rated in this way is quite high. Flexible hoses are available in 3 general pressure ranges: low, medium, and high. When hosing is selected for a particular location in a plant system, pressure and vacuum ratings must be considered. In addition, environmental conditions, Especially temperature levels inside and outside of the hose will also help to determine the type of hose that is best suited for the job. The next step after selecting the appropriate hosing is, of course, installing it for operation. There are some simple but important rules to follow to ensure proper installation and an extended life for the hose. For instance, hosing should never be twisted as it is installed. Twisting can cause hose fittings to loosen, which could cause leakage when the system is in operation. Hoses should never be stretched when installed. A good rule of thumb is to allow an extra 5 to 10% of the total hose length for slack. This also provides for freedom of movement when system pressure is exerted on the hose. When bending hoses, be sure to follow the manufacturer's recommendations for minimum bend radius. The minimum bend radius is usually based on size, reinforcement thickness, and pressure ratings of the hose. Kinking and damaging stress can result when a hose is bent too sharply. In addition, the bursting pressure of the hose is likely to be reduced below its rated pressure. Finally, hoses should be protected from rubbing against other plant equipment. This can cause undue wear to the outer layers of the hose as well as possible damage to the other plant equipment. Protective shields or supports may be necessary to keep the hose out of contact with other plant components.